Assalamualaikum and salam sejahtera. Okay class, for today's video we will proceed to subtopic 7.2, which is speed time graph. So in this subtopic, your first learning objective is how to draw speed time graph. In your previous lesson, you already learned how to draw distance time graph, right? But now for this subtopic, we are going to learn how to draw speed time graph. But before that, let's look at this one. Okay, this is in a speed time graph. The vertical distance, the vertical axis represent the speed of motion. This is the vertical. The vertical axis represent the speed of the motion, and then the horizontal axis represent the time taken. This one is the time taken. This one speed. The vertical axis, the horizontal axis is time. Okay, now, and then the extra information here, the gradient of the graph. This is the gradient of the graph. Okay, the gradient of the graph represent this one. This gradient of the graph represent the rate of change of speed. The rate of change of speed with respect to time. That is what we call as a acceleration. Okay, so look at this one. How do you draw a speed time graph? So a speed time graph can be drawn if the following information about the motion is obtained. So in order for you to draw a speed time graph, you must need to know these two information in order for you to draw this speed time graph. So the first one is you need to know speed time table. Okay, and then the second one is you need to know the equation that represent the relationship between speed and time. So you need to know these two, speed time table and also equation of the relationship between speed and time. Okay, now let's look at how do you draw a speed time graph based on speed time table. This is what we call as speed time table. Speed time table. There is the information of speed and there is an information for time. So this is what we call as speed time table. Okay, now look at the example 10. The table below shows the change of speed of Encik Azizul's car for a period of 5 seconds. In 5 seconds, this is how the speed of Encik Azizul car. Okay, now the question asks you to draw a speed time graph based on the given table. So this one lah. So what should we do? How to draw? Okay, let's look at this step. Okay, the first step that you need to know is you need to choose appropriate scale to represent the given speed and time. That is the first one. You need to choose the suitable scale, and then for the second one, you need to plot a point to represent each pair of the value, and then number 3 is you need to join all the plot using a ruler to obtain the speed time graph. Okay, so like this. I will show you how to draw speed time graph. Okay, so the first thing that you need to know is you need to determine the scale for time and also speed. Remember? Okay, this one. Okay, for example, this one and this one. Okay, the vertical axis represent what? The vertical axis, I already told you just now, the vertical axis represent the speed. The vertical axis represent the speed, and then the horizontal axis represent the time. Okay, so and then what should you do? The first thing, in order for you to draw the speed time graph, you need to choose a suitable scale. So for time, as you can see, for time in second, it is 1, 0, 1, 2, 3, 4 and 5. So just do it like this: 0, 1, 2, 3, 4 and 5. Okay, that's it. And then after that, look at the speed. Speed 0, 10, 20, 30, 40 and 50. So from here we know that the scale can be 10, 20, 30, 40 or 50, or you can do like 5, 10, 15, 20, 25, 30, 35, 40. You can do the scale like that also, but to make it easier, just choose the scale 10. So 0, 10, 20, 30, 40 and 50. Okay, this one like this, and then what should you do? Okay, so before after you determine the scale, and then the second thing that you need to do is you need to what? You need to plot a point. Look at here. So for time 0, the speed is 0. So for time 0, speed also 0. So this one lah. Okay, and then for time 1, the speed is 10. Time 1, speed is 10. So like this. Okay, and then when time 2, when the 2 second, the speed is 20. For 2 second, the speed is 20. Okay, like this. Okay, now, and then for 3 second, the speed is 30. So you need to use your ruler, this one. Okay, and then for 4 second, the speed is 40. So for 4 second, the speed is 40. The speed is 40. Okay, this one 40, and then the last one for 5 second, the speed is 50. Okay, like this. Okay, now done. After you done plot each point, and then what should you do? You need to join all the plotted point that you have drawn just now. So to make it a straight line here. Okay, so you need to draw like this. Okay, supposed to be, this is all the point touch the straight line, just because I don't use a ruler, then the point, it's a little bit it's not that perfect lah. So it's supposed to be like this, this is just roughly because I don't use the ruler. So this is the actual one, this is the right one. Okay, this is how the straight line look like. So all the point touch the straight line. So this is how you do it. This is how you draw the speed time graph. Okay, but before that, don't forget to, speed is in unit. What unit for speed? Speed is in meter per second. So don't forget the unit meter per second. And then for time is second. It is second. So like this. This is how you do it. Okay class, now look at example 11. So the rate of change of speed of an aeroplane that is landing is given by the equation V. This is V for speed, equal to 800 minus 1600 T, where V is the speed in kilometer per hour and T is time in hours. Draw a speed time graph to represent the landing of the aeroplane for the period of time is greater than or equal to 0 and less than or equal to 0.5. So what should you do in order for you to draw the speed time graph? Okay, let's look at this one. You need the first thing that you need to do is you need to construct a speed time table as shown below. This one, using the equation V is equal to 800 minus 1600 T. Okay, now after you draw the table, time and speed, you only know the information for time, which is this one, right? Time is in between 0 and 0.5. So in order for you to draw speed time graph, you need to at least 2 points in order for you to draw the speed time graph. So that's why this table here, it's only give you the times 0 and 0.5 only. But if you want to make it more than 2 points, then it's okay. You can do it like that. For example, like 0, 1, 1, 0, 0.2, 0.3, 0.4, 0.5. You can do it like that. But in order, that is the you can do like that also, but for this one it choose only 0 and 0.5 because in order for you to draw speed time graph, you need only at least 2 points. Okay, so don't make it harder for you, just do at 2 points only, which is 0 and 0.5. Okay, after you already know the time, you don't know the speed, which is v in kilometer per hour, but the question give you the information, this one, right? V is equal to 800 minus 1600 t. So in order for you to find the speed of the aeroplane, you need to substitute time. For example, time in hour is 0, so you need to substitute when t is equal to 0. Look at this one. When t is equal to 0, you need to substitute in this equation 800 minus 1600, 0. So the answer will be 800. So this one, you will get the answer 800 from the equation given. Okay, and then the next one is for the time 0.5. You need to substitute in the equation also, which is when t is equal to 0.5, substitute, then you will get the answer is 0, like this. So, and then after you already fill in the speed time table, then what should you do? You need to draw speed time graph. So for the vertical, it's represent the speed. For horizontal axis, it is represent the time. So for this one, okay, now you need to plot. For time 0, the speed is 800. So for time is 0, speed is 800. So this is the first point that you need to plot. And then the second one, for time 0.5, the speed is 0. For time 0.5, speed is 0. So this one. And then after that, you do the straight line that touch the 2 point here. Okay, just like that. Okay, so okay, now class, we are going to proceed with our second learning objective, which is what is the relationship between the area under a speed time graph and the distance. So what is the relationship between area under the speed time graph and the distance? So don't look at this one, just look at this one. Okay, so what is the relationship between area under a speed time graph and the distance traveled? So what is the relationship? So let's look at this one, the green box here. Okay, now, okay, so the area, okay, just now. Okay, let's look at this one. Understand this one first. Area under a speed time graph is the same as the distance traveled for the same time interval, or in general you can conclude that for a speed time graph, area under the graph is equal to the distance travel. So in order for you to know the distance travel of the motion, you need to find the area under the graph. Okay, once again I told you, in order for you to find the distance travel of a motion, you need to know the area under the graph. Okay, so what is the area under the graph? This one, this is how it looks like. This is what we call as area under the graph. This one, sorry, wait. Okay, this is what we call as area under the graph. This one. Okay, so for a speed time graph, so the first thing that you need to know is you need to look at the graph. Is it the graph a speed time graph? Yes, it is a speed time graph. And then after you know that this is the speed time graph, then you can apply this one, which is area under the graph is equal to distance travel. So this one, area under the graph. So in order for you to know the distance travel of the speed time graph, you need to find the area of the graph. Okay, let's look at example 12. Look at example 12. Calculate the distance traveled in each motion based on the following speed time graph. Okay, so this one speed time graph. The question asks you to calculate the distance travel. Okay, so as I told you just now, in order for you to find the distance, or in order for you to calculate the distance traveled, you need to know the area under the graph, because distance traveled is equal to area under the graph. So look at this one. So this is we want to know the distance traveled, right? So we need to calculate the area. What is the area under the graph? This one. Okay, so look at A, the solution. Okay, so this is area under the graph. So it take the solution take out this area under the graph. So it will look like this. So this one is 5. Okay, this one is 10. And then this one is 4/5. So what should we do? We need to find the area under the graph in order for us to know the distance travel. So distance is equal to, this one is the shape of trapezium. So formula of trapezium is 1/2 times 1/2 times base time A plus B, which is the side of this one. Okay, so look at this one. Distance is equal to area of trapezium. So 1/2 times with base 4/5. And then this one in hour, right? In hour. And then multiply with 5 plus 10. So after you calculate, you will get the answer is 6 kilometer because it is distant. So it must be in kilometer based on this one, kilometer. Okay, so that's it. This is how you do it in order for you to calculate the distance travel. Class, let's look at example B. Okay, for example B, this is speed in kilometer per hour, and then the horizontal axis, it is time in minutes. So okay, as compared to example in A, it is kilometer per hour and this one is in hour. So the unit is the same, right? But for B, this one kilometer per hour, but this one is in, the time is in minutes. So this is the problem here. But before that, okay, it's okay. Just I will explain later. But let's look at the area under the graph. So this one is the area under the graph. So it will, if you take out, so it will become like this. So this one is 80 and this one is 40. Okay, now this one is 6, right? But this one in minute. So you need to change minute into hour. Look at to make it this the unit equal. So you need to change minute into hour. So 6 you need to divide by 60. So after that, what should you do? You need to find the area of the trapezium lah, in order for you to calculate the distance. So it is equal to 1/2 times with 6/60 times with 40 plus 80. So you will get the answer is 6 kilometer also. So this is how you do it. Okay. Okay, now class, let's look at example 13. Okay, example 13. Okay, the speed time graph shows the speed of Mr. Liu's car for a period of 36 minutes. So the question asks you to calculate the total distance in kilometer traveled by Mr. Liu's car for the period of 36 minutes. Untuk tempoh masa selama 36 minit. So it means that from 0 to 36 minutes. So you need to find the total distance. So in order for you to find the total distance, you need to find the area under the graph of this one. Okay. So look, okay, this is how I do it. Okay, let's look at this one. Area under the graph for this one. Okay, I divide into 3. Okay, okay, this one, the first area under the graph that you need to find, and then this is the second one. Okay, and then this one is the third one. Okay, you need to find all the 3 shapes, all the area under the graph of these 3 shapes. So this is how the shape is look like. So now look at this one. So the base is 10. The base is 10. The height is 72. Okay, we done already for this area under the graph. Now look at this, the second one. The second one is the shapes of trapezium, right? So from 10 to 20. So the base is 10. This side it is 72, and then this side is 40. Okay, and then the last one is the base. So 36 minus 20. 36 minus 20. Okay, 36 minus 20, you got 16, right? 36 minus 20, 16. Okay, and then the height is 72 for this one. 72, and then for this one, the height is 40. Okay, but it is not settled yet because look at the speed. The speed is in kilometer per hour, but for time it is in minutes. So you need to change the base into hour lah. So 10 you need to divide by 60, 10 divide by 60, and this one also divide by 60. Okay, and then after that you need to calculate. Okay, okay, I hope you can see. Okay, 1/2 time base, which is 10/60, times with, oh okay, sorry class. Okay, this one is triangle, right? So 1/2 time base time height, which is 72. Okay, and then plus with, okay, this shape pula. This one is trapezium. So 1/2 time base, which is 10/60, times with 72 plus 40. 72 plus 40. Okay, and then done for this one. Okay, now the last one, the last shape of trapezium is 1/2 times 16/60 times with 40 plus 72. 40 plus 72. Okay, and then you calculate and you will get the answer is, this one is 6, this one is 28/3, and for this one is 224/15 kilometer. So kilometer, and then after that you need the total. You need to total all this. You will get the answer is 30.27 kilometer. This is the total distance traveled by Mr. Liu. Okay, now after that, okay, we done for question A. Now look at B. The question asks you to calculate the average speed in kilometer per hour of Mr. Liu's car for the period of 36 minutes. So the question asks you to find the average. So you already know the total distance. Okay, now look at B. For B, you already know the total distance, right? Okay, so average speed, the formula is speed over time. Okay, so average speed for average speed, okay, the speed is, oh sorry, not speed, average speed, this one is distance, sorry, distance over time. In order for you to find the average speed, you need to know average speed is equal to distance over time. So for distance, we already got the distance, which is the total distance is 30.27 divided with time. So what time? The total time taken by Mr. Liu's car is 36 minutes. To 36 minutes, you need to, this one in minutes, okay, you need to change it into hour. So 36 divided to 60. So you will get the answer is 50.45 kilometer per hour. So that's it. 50.45 kilometer per hour. So this is how the answer. Okay class, let's look at our third learning objective, which is how do you interpret speed time graph and describe the movement based on the graphs. So this is how the speed time graph. So if you look at this one, this is speed in meter per second, and for the horizontal axis, it is time in second. So if you can look at this one, this is for this speed time graph. This one we call it as acceleration, and also for this one we call it as uniform speed. And for this one, the gradient, negative gradient, we call it as deceleration. Okay, I will go through one by one for each of part. Here, look at the first one is PQ. PQ is increasing, right? The positive gradient. So look at PQ. For PQ, the speed of object is increasing from U to V. From U to V, the speed of object increasing, and then the gradient of the graph is positive. Hence, the rate of change of speed also positive. And then this one is acceleration because it is a positive gradient, so that's why it is acceleration. So the acceleration is equal to change of speed over change in time. What is the change of speed? This one, u and v. U for initial speed and v for final speed. So the change of speed, it means that v minus u over change in time. So change in time, so how many time it takes for the change of the speed. Okay, and then for the last one is the area. The area of the trapezium, before this I already told you the area under the graph is equal to, or it is represent the distance travel in the period of this one from 0 to t1 second. Okay, so remember this one is acceleration, and then the gradient of the graph is positive, and also it will automatically, we know that the rate of change of speed is positive, and this one is the acceleration. So formula for acceleration is the change of speed over time, over change of time. So change of speed, it means that final speed minus with initial speed, and then for change in time, t1 minus 0. So that is how you will find the calculate the acceleration. And then the last one is area of the trapezium of this one is equal to the total distance travel. Okay, that's it for PQ. Now QR. QR is the uniform speed. QR is the uniform speed. So for QR, uniform speed, it means that there is no change of speed. It means that the motion, or for example like the car is moving, but it moving with the uniform speed. So that is what we call it as no change of speed, or we call it as zero gradient. Okay, and then next, the object move at uniform speed. Uniform speed, it means that the object is moved with the same speed all the time. From T1 to T2, the object move with the same speed. Okay, now the third one is the area of the rectangle B. This one, the green one, that is, okay, the rectangle of B is the area under the graph that represent the time, that represent the distance travel for the motion from T1 to T2. Okay, that is the explanation for QR. Now RS. Now look at RS. For RS, this is the deceleration. Because of what? Because the gradient is negative, so the speed of the object decrease. So it means that for this RS, the speed of the object decreases. So it means that it is deceleration lah. So the gradient of the graph is negative, hence the rate of change of speed also negative. So the deceleration, the formula is the same as acceleration, but for the deceleration, your final answer will you will get negative. Because of what? Because deceleration. Okay, and then the next one is there is no change in the direction. That is, the motion of the object remains in the same direction. No change in direction. And that is, the motion of the object remains in the same direction. So the last one is the area of the triangle C, the pitch one here, represent the distance travel from the period T2 until T3. That's it. That is how the interpretation for the speed time graph. This one, Okay, now class, let's look at example 14. Okay, the speed time graph shows the motion of Puan Salina's car for a period of 50 seconds. This is the motions of Puan Salina's car. Okay, this one, Okay, and then the question asks you to calculate the rate of change of speed in meter per second for the first 5 seconds. So what is the first 5 seconds? The first 5 seconds is in here. The first 5 seconds, So this is the first 5 seconds. So the rate of change of speed is equal to change of speed over change of time. So rate of change of speed is equal to change of speed over change of time. Okay, and then what should we do? Change of speed. So look at the speed. Look at the speed from 20 to 40. So the change of speed, the change of speed is final speed minus with initial speed. So final speed is 40 and then the initial speed is 20, like this. So it is in meter per second. Okay, over with change in time. So for the first 5 minutes, for the first 5 seconds is 5 minus 0. So we will get 5 seconds lah. So and then you key in your calculator, then you will get the answer 4 meter per second. Okay, now done for A. Now look at B. The question asks you to describe the motion of the car. Describe the motion of the car for the second 5 second. Untuk 5 saat kedua. For the second 5 second, it means that 5 saat kedua. This is 5 saat. This is 5 second. First 5 second. This is second 5 second. This is first 5 second. This is second 5 second. So remember, this is second 5 seconds. So here lah. This is question B asks you to describe the motion. Okay, this motion, this one is acceleration, right? Before this, I explained to you, and this one is the uniform speed, and then this one also the acceleration. So this one is uniform speed. So we can describe like this: the car move at a uniform speed. So at uniform speed to at what speed? So uniform speed at 40 meter per second for how long? For the period of 5 seconds. That is how you describe. Move at uniform speed of what speed, and in how many seconds. So this one, at uniform speed of 40 meter per second for the period of 5 seconds. That is how you describe. There must be 3 things, which is whether it is uniform speed or acceleration or deceleration, and what is the speed, and then how many time. Okay, macam tu, like that. So done for B. Now look at C. For C, the question asks you to calculate the total distance in meters. Traveled in the period of 15 seconds. Travel in the period of 15 seconds. So it means that for all the time from 0 to 15 seconds. So you need to know the total distance for this one, and this one. So in order for you to find the total distance, you need to calculate the area under the graph of this part. There is 3 parts: part A, part B, and part C. So like this, this is how you do it. 1/2 times 5, and then times with, this is trapezium, right? This one trapezium, this one trapezium, but this is the only one is rectangle. So 1/2 times 5, which is the base, and then the height is the side is 20 and 40. So 20 plus 40, then you will get the answer is 150. Same goes as this one. Okay, this one is rectangle, right? So the base is 10 minus 5, you will get 5 lah. 10 minus 5, you will get 5, and then the height is 40. That's it. Then you will get the answer is 200. Plus with this one, the last one, which is the rectangle trapezium. 1/2 times with 15 minus 10, which is 5, times with 40 plus with 60. So you will get the answer is 250. Then you add on, you will get 600 meters. Okay, that is how you do it. Okay, now class, let's look at our next learning objective, which is how do you solve problems involving speed time graph. So look at example 16. The speed time graph shows the motion of a car for a period of 14 seconds. So calculate the average speed in meter per second for the first 6 seconds. The average speed. So in order for you to know the average speed, so average speed is equal to distance over time. So you need to find the distance and also time. The time you already know, which is 6 seconds. Now find the total distance for the first 6 seconds. So as you can see here, okay, total distance traveled. In order for you to find the total distance traveled, you need to find the area under the graph. So this is the trapezium shape. This one, total area under the graph. Okay, so 1 over 2 multiply with 4, which is the base, and then 5 plus 10. And then, okay, for the first 6 seconds, right, this one, and also this one, this one also. This one, and also this one. So this one first lah, this one. So this one, 1 over 2 multiply with 4, multiply with 5 plus 10. So you will get 30 for this part, for this shape. And then another one is rectangle. Rectangle is 6 minus 4, you will get 2. 2 multiply, this one is rectangle. So base time height lah. 2 multiply with 10. So 2 multiply with 10, this one. 2 multiply with 10, you will get 20. So 30 plus 20, you will get the answer is 50. So after you get 50, okay, remember average speed is distance over time. So 50 meter, you already get the answer. Divide with time. For the first 6 seconds, this is the time, which is 6 seconds. So you will get the answer is 25 over 3 meter per second. Or you can change it into decimal. Okay, now done for A. Now look at B. Okay, now look at question B. Calculate the value of t if the distance traveled by the car for the first 4 seconds is half the distance traveled at uniform speed. It means that distance travel from here. Sorry, wait. Distance travel here. Okay, this one. Distance travel here is equal to half of the distance traveled at uniform speed. This one. At uniform speed. So it means that, okay, distance travel, area of trapezium, this one, area of trapezium, which is the distance travel for the first 4 seconds, is equal to the half, 1 over 2 of the distance travel at uniform speed. This one, 1 over 2 times area of rectangle. This is how you do it. So area of trapezium, 1 over 2 multiply with 4, and then multiply with 5 plus 10. 5 plus 10 equal to 1 over 2 multiply with, okay, 1 over 2 multiply with uniform speed. So the base is t minus 4. So t minus 4 multiply with high. The high is 10. So that's it. This is how the equation. Okay, you solve for this part, the left side, so it will become 30 equal to, and then you solve this one, you will get 5t minus 20. Then we want to know the value of t. So you solve for to find the t. So t is equal to 10, like this. T is equal to 10. Okay. Now for B, done for B. Now C. The value of v. The value of v if the acceleration for the last 2 seconds is 3.5. The value of v if the acceleration of the last 2 seconds is 3.5. So the last 2 seconds is 3.5. Okay, look at this one. See, acceleration, we know that the acceleration is this one. This one acceleration. So we okay, acceleration for the last 2 seconds is 3.5. So the acceleration, we know that 3.5 meter per second per second. So v minus 10. V minus 10. V is what? V is for final speed. 10 is for initial speed. Okay? V is for final speed that we don't know the value, but we know the value is for the initial speed is 10. This one. This one, this one initial. This one initial speed. Initial. This one is v final. So v minus 10, which is initial speed, divide by 14. 14, which is this one, 14 minus t. We already know the value of t, which is 10. So 14 minus 10 is equal to, we already know the value of acceleration, which is 3.5. Then we solve this equation, and then 4 multiply with 3.5, then you will get the answer is 14. And then v minus 10 is equal to 14. So negative 10, you bring it to the right. So you will get the answer v is equal to 24, like this. This is how you do it.